Hello everyone, welcome back. This is Engineer Hussein Mwasapi. Alright, so in this video we'll be looking at a physics exam revision review. As you can see, we have a question that I have derived from one of the past paper questions that were given. Alright, so before we begin, do not forget to like, subscribe, as well as hit the notification bell icon so that you can receive notification about our videos. All right, let's get to it. Okay, so it says that dimension analysis plays a vital role in the quantitative analysis of physical quantities. The first question is asking us to say, what is a physical quantity? Now, in a nutshell, we can simply just say physical quantities are basically measurable quantities, but we just can't end there. Rather, we can say that a physical quantity can be defined to be a property of a physical system that can be measured or described using numerical values. With that said, we can write that a physical quantity, that is for part A here, part A, we can say that is simply a property of a physical system. A physical system, bear with me with my handwriting, that can be measured. So the key thing is that these are systems that can be measured, isn't it? Or we're saying they could be described. Now that description is using what we refer to as numerical values. Just like that. So what I'm trying to say is that these physical quantities are basically quantities like force, velocity, acceleration, and so on and so forth. In a nutshell, we could say the vectors or scalar quantities that we have. All right, for part 2, it says state 2 applications of dimensional analysis. So we have quite a number of applications, but we'll just mention the major applications we have. I won't just give 2 or give 3. So we can say that the application of dimensional analysis is firstly in the derivation of equations. That's the first one. The second one we can look at is unit conversion. Unit conversion. The last one I can give is simply just checking the correctness of an equation. Checking correctness of an equation. Put it just like that in simple terms. The last one is asking us to say state any 2 limitations of dimensional analysis. So what are these limitations of dimensional analysis? So the first limitation we can look at is that it does not consider fundamental constants. So does not consider fundamental. Now I want you to understand something. When we say it does not consider fundamental constants, what I'm trying to say is that if you look at constants that have an important impact on the physical system, like the speed of light or the Planck's constant, those constants are never considered. So in as much as they are, or let me say they play a vital role in the physical system, they are not considered when it comes to dimensional analysis, and that is quite a limitation in our scientific calculation. Other than that, the other limitation we have is that we cannot determine dimensionless constants. Dimensionless constants can never be determined. That's one issue that's there. Even as you are doing calculations, you'd find that the dimensionless constants can never be determined. So we say that cannot determine dimensionless constants. Be mindful about that. Then the other thing that is there is that mostly we ignore numerical factors. This one is a bit self-explanatory when you say ignoring numerical factors. So these are the basic three limitations of dimensional analysis. So in most cases, I think I'll be using red for most of my physics exam review questions, because I need to be highlighting what the question actually says. So this is one of your sessional questions that was brought, I guess that was 2017 to 18 intake. Yeah, so remember, in a nutshell, a physical quantity is basically just a measurable quantity, or in other words, you could say it's a property of a physical system that can be measured or described using numerical values. And the two applications of dimensional analysis is the deriving of an equation, unit conversion, checking the correctness of an equation. Then the three limitations that we have, sorry, the two, not three, is that you cannot actually consider the fundamental constants like the Planck constant, the speed of light, or cannot determine dimensionless constants. Other than that, we ignore numerical factors. So this is literally the end of our first question. All right, thanks for watching. If you have queries, you can always reach me on WhatsApp on the line 077 149 5252. All right, remember, slow progress is better than no progress. And don't forget to strategize for becoming a statistic. And let's push for that A+.